Hello everyone, this is the third lesson on utilities and we're gonna treat how to design utilities using the grand composite curve. Remember, the grand composite curve is the heat cascade of the problem represented in the temperature versus delta H diagram. Temperature is displaced temperature. It is half the minimum approach down for hot stream and half the minimum approach up for cold stream. The usefulness of the grand composite curve is that it represents heat flows across temperature boundaries down the problem at different levels of temperature. Because of that, it shows the energy profile of the problem, where heat is in excess or in defect. Where meaning level of temperature. For example, in incoming intervals, it is when the enthalpy is reduced with decreasing T. These are enthalpy consumption regions because the heat flow decreases with temperature. Remember that down in temperature is the spontaneous sense. On the contrary, in outgoing interval, the heat flow increases with temperature decreasing in the spontaneous sense, and then there are enthalpy production or excess regions. This consumption is wrong, it must be production. In particular, this diagram is very useful to understand utilities when plotted on it. Remember that inside the grand composite curve there are hot and cold streams recovering heat perfectly between them at each temperature level. And then what is represented in this curve is the excess or defect heat flow needed. So, in excess region, there are some heat that can be directed down in temperature that must be taken out. And in defect region, you will need some heat arriving to balance this need. So the grand composite curve represents the temperature versus heat characteristic of the problem, the enthalpy flow in excess for each temperature level. In particular, it let us visualize easily the pinches and quasi-pinches. It is when the heat flow down the problem is zero or near zero, as well as the heating or cooling requirement at each temperature level of the problem. The heat exchange of the process with the surrounding, it is the use of utilities, takes place only at the hot and cold end of the problem in temperature. It is in the highest or lowest point of the curve in the enthalpy coordinate. It is the minimum heating of the problem is exactly the enthalpy coordinate of the last point, and the minimum cooling needs of the problem is exactly the enthalpy coordinate of the lowest point of the curve. This is because the reentrant areas of the curve, what we call pockets, must serve themselves. This is the heat liberated up, is the heat needed down. And for cooling, this is the same thing. The heat liberated up must serve the heat needed down. And this is true even at the last point of the pocket, where the difference between hot and cold stream is exactly the minimum approach and the recovery can take place. Besides, if heat is taken from a pocket here to a cold stream, then must be restored later to the balance be maintained. Then, this behavior let us represent utilities in front of the grand composite curve in a way that is very useful to calculate it. We must fill the gaps up with heating and fill the gap down with cooling. We can see the utilities in amount and level confronted with the needs of the problem. And this is also true for pseudo-utility design. For example, sometimes we integrate reactors or separation system, the reboiler or the condenser, or turbines or engines with the problem, and this can be done confronted with the problem in level and amount. So we can represent a grand composite curve of the utilities confronted with the grand composite curve of the problem. And this is a very useful tool to design utilities. Here you can see how can be readily found the maximum amount of steam at this level or the minimum amount of steam needed at this level, or the maximum slope of these flue gases that give us the minimum natural gas consumption of this turbine or engine, or the maximum amount of water that we can preheat and vaporize to produce steam at the concrete level. Remember that we can arrive till touching the process curve with the utility, because when touching hot stream are the minimum approach up the cold stream at this point. And all these things are why the grand composite curve is a so useful diagram to design utilities. And this is all.